How was the rest of the lunar eclipse? How was that for you? Wow, I just hit my mic. How was that for you?
Well, it was disappointing, technology wise. Like, I learned a bunch of valuable life lessons about how to make the whole technology stack between me and the telescope and the internet work, but I only figured it out sort of past totality as we were coming out the other side. So it was the image was very pixelated, was very compressed, and I didn't know why, and I couldn't make it go. And we were sort of halfway out, like I said, out of totality. And I'm like, man, I can't get why the image sucks. And Chad is watching in the chat. That's my editor. And he goes, are you using TeamViewer to be able to see to show off the image? I'm like, yeah. He goes, well, they've got two modes, one that's high bandwidth and one that's high quality, or one that's high speed and one that's high quality. So check which one you have. And I was like, oh, it's high speed, which made it very compressed. And so I switched over to high quality and it looked a million times better. So, but after the important parts had already happened. So the last part of it looked great. And then I had just a bunch of other technology issues. So I had learned as you go, but it'll work in the next, next time this happens in about 3 years. So,
Right.
so
Yeah. Well,
lessons learned.
yeah. Well, thanks so much. Everybody's like, yeah, I'm messing with the volume, guys, because I need to hear him too. So my mixer, guys, I'm testing things out.
Yeah. See, this is it. Like, sorry, this is, if you want to be part of this experience, you're going to have to be part of the experiment. And so, you're just going to keep changing everything. So anyway, it was fun to give it a try, but I was more like, and we had a perfect view on that telescope, but overall, my technical chops weren't up to speed to actually be able to do it justice. So, next time.
Next time. Yeah.
And like I said, I won't make that mistake again. I'll just make a bunch of other mistakes.
Well, you did a great job at keeping that, because everybody was like, "Why is it so shaky?" And I was like, maybe there's wind,
Yeah.
And then you're like, "No, I'm having to do this manually." But yeah.
No. Well, so it was. I mean, it was windy, and I don't know if you noticed. The wind knocked over the SpaceX Starhopper and smashed it up. So there was a lot of wind around that time.
Oh wow.
Hurricane force winds hit SpaceX in Boca Chica. So that's a problem. And then also the telescope there's something misconfigured on that telescope, and so it doesn't track properly. And when you try to pick any object, and it's off by about half of lunar distance, including the moon. And the problem with the moon is that it actually has to be tracked differently than any other object in the night sky, because the moon is moving around the Earth. And in the view of a telescope, it's actually pretty noticeable. And so the problem is that you have to either track the moon or track the sky. And you can't do both at the same time. And in this case, I was having to manually keep moving the telescope back to view the moon. So anyway, a million lessons learned. We just will get better.
Yeah. No, I mean, everybody here appreciated
full
it.
refunds going out to everybody who paid
me. Full refunds.
Actually, some people donated over on our YouTube feed. So it was awesome.
Yeah.
It was really nice of people.
Yeah, that was incredible.
You did it. Looks like you got it perfect.
Yeah, no, I've been sitting here adjusting it. I'm driving myself nuts with that. Because there's 2 things there's like 5 things that I'm monitoring right now, and my mixer just got like 10 times more complicated with a dual PC setup. So
have you considered more monitors?
I have 5.
You only have like 2, right?
I have 5 now.
Oh, you have 5 now. Okay, good. Well, now you're in the zone.
I'm encased right now in monitors.
I know, it's like wrap around.
It is. I have one up here, and I have one over here, and over here.
Yeah, play some like Elite Dangerous or something, and then you're just like
so immersed.
Yeah, exactly. I need 2 more for sure.
Yeah. No, I could see this. I'm still debating this setup as far as some of these I have turned, and I don't know. I might need to. There's some refining I have to do here. I'm not 100% sure though yet. So
But you got a new machine too, right?
Yeah, so
Good.
it's a two PC setup right now. So I have one that runs video games or Space Engine,
Oh, and one's the streamer.
and one's yeah, because OBS is a CPU hog.
Yes, it is.
So yeah, it will be dedicated to that. But I also have other background processes on that one still too. So
Yeah.
yeah.
So this means you're gonna have time to play video games.
I hope. Probably not.
Yeah,
Probably not.
probably not.
Probably
Yeah.
not.
The way I play video games is I just buy video games on Steam and I just let them pile up.
Yeah, yeah.
I'm sure I'm not the only one.
No, I have a few of those, but I mean, I don't remember the last time we played a game.
Yeah.
I actually have
No, I
no
played.
idea.
What did I play? I played yesterday. I played Don't Starve, Hamlet. So
Oh,
I'm,
yeah,
I still have a little tiny bit of time to play.
yeah. No, I see you and Ian sometimes playing. Ian's playing Diablo sometimes.
Oh, is he? Okay.
I
Yeah.
think it's Diablo 2 he's playing sometimes, but
Yeah.
it always makes me laugh when I see like fellow astronomy nerds playing video games.
Yeah.
It's great. Let's see here. 35 unplayed games.
Yeah. Oh, that's it? I have thousands probably. Thousand
Yeah.
unplayed games. And the way I justify it is that I have kids, and so I've got this big family library that the kids can play, right?
Oh yeah, the family share is a great thing.
Yeah, yeah, exactly. So it's for them. It's not for me. I'm not a compulsive game hoarder. I'm I'm making sure that my family is always entertained. They can never hear the dark, existential, lonely dread silence.
And it's true. Someone just said that I think that about 99% of Steam users haven't played 80% of the
Yeah,
games in library. Yeah.
yeah, yeah, exactly.
Exactly. Yeah, you wait for those Steam sales and then you do
Yep,
that.
and then you just pile them up.
Yeah,
Kids
and
are being
Deliver.
so smart.
Yeah, have you played Deliver Us the Moon?
No, I wonder if I even own it.
I
I'll
feel
find out.
like did that one come out? I feel like I like maybe 2 years ago or something.
It is. I do not own it. There you go.
Yeah, I'm not. I vaguely remember hearing about that one. I might have met the devs with that one.
Hmm.
Maybe,
But
maybe.
Moon, I have Moon Hunters, To the Moon, The Sun and Moon, Earth 2150, The Moon Project.
Yeah, there was one that, and it might be that one that they're talking about. Deliver Us the Moon. I think that might be. I don't know if that's like a sandbox where you're kind of on the moon and you get to experience the physics of it. I'm not sure though.
Okay.
Yeah, yeah, yeah. No, I don't. I haven't played video
Once I
games in a
work through
while
my
though.
backlog of 1,000 games, I'll get right on that.
So soon, TM.
Yeah, exactly.
Yeah.
Like
So
to a retirement home.
we haven't watched the Fast Radio Burst one yet. But I'm waiting for people. Does anybody have? Everybody's talking about games. Does anybody have any questions for Fraser with all the high tech stuff?
About games?
About games? Well, you said something that happened with the Star Hopper. I didn't hear about that, or maybe I did, and
Yeah,
I just didn't read about it yet.
yeah, it just happened. Just happened yesterday. So the the SpaceX Starhopper. This is the prototype of the Starship that's built out of stainless steel, and really it's just a water tower with a fuel tank and a bunch of Raptor engines. And it got hit by 50-mile-per-hour winds on Tuesday night.
Yikes.
And although it was tied down, it wasn't strong enough, and it crashed over and is all smirched.
Oh man.
So Musk had been predicting that they would start to do tests within the next 4 weeks of the Starhopper. And although that's not its official title, that's what we all call it. And then but he had said but there could be other issues that'll come up, unforeseen problems. And I think this definitely qualifies as an unforeseen problem. But I mean, the thing came together so quickly. I can't imagine that's going to take them much more than an extra few weeks, a month to get caught up and ready to launch again. So
Right.
yeah.
Yikes, though. Yeah.
Well, yeah. I mean, it shows that. I mean, part of it is that is a very windy part of the world. My wife attests to the windiness of Texas, and she's like, "Yeah, I'm not surprised that happened." And so it's interesting. I mean, if they're going to use that facility as a place to potentially even launch rockets in the future, they have to really consider the strength of the winds that come through there.
Right, right. And someone just said, I think Musk said that the hopper will be fixed in 2 weeks.
We'll see what happens. Yeah, maybe. And then something else will come up. I mean, this is standard. We're on Musk time now. Time has no meaning. Everything is relative. Like on the one hand, we are like what the Falcon Heavy took like years and years long, almost a decade longer than I think they had originally planned. But on the other hand, watch the video of 2 rocket boosters landing side by side. Like,
yeah, no, that was
eventually.
still incredible. Someone did ask what you think about Kerbal Space Program. If you play it, do you like it?
Yeah, I played it. I'm okay. I mean, what Kerbal was great for was teaching me the basics of orbital mechanics in a way that doing my science reporting, my space reporting, never had done before. And so when you actually learn how to, say, circularize an orbit, how to at apogee, and how to do orbital maneuvers, docking, and how to do an insertion orbit to go to the moon and things like that, you just learn so much in this very compressed time that now I'm able to take that back, and as I report on stories and do videos, I understand the underlying mechanics so much better. So I always say that I learn more in playing a couple of hours of Kerbal Space Program than I have in years of being a journalist.
Yeah.
Right. So, but at the same time, I mean, you see what things like Scott Manley and there's another streamer.
I'm trying to
EJ
SA.
Yeah, and he's just like he's got this solar system spanning civilization in his Kerbal Space Program, and he whips up all kinds of really cool vehicles, helicopters and stuff, and I just like, nope. Nope. No,
I wish KSP had multiplayer. It doesn't have multiplayer?
I wonder if someone's done that.
Really? I feel like that would have been super fun. How could you not?
Yeah. Yeah, so that's it. So I think it's great. I think it's a powerful teaching tool. I recommend it all the time in my videos, especially if people want to understand why the sun is so hard to get to, or why the farther you orbit from the Earth, the slower you go. Right? It's a weird counterintuitive thing, but it's the way it works.
Yeah.
So helpful.
Yeah, KSP bought that before it was released on Steam. Oh, okay. So someone says there's a mod.
Okay.
Kind of works. Gotcha. Yeah, I'm. Well, I can bring up some space news too, because there has been space news that's come in that maybe we can talk about.
Oh, yes.
Have you read any that maybe you haven't done an episode on, but you're going to, or?
Well, I just wrote up my newsletter for tomorrow, so it's all fairly fresh in my head. Let me see.
Yeah, we're both going to have to look because nobody has questions right now.
Yeah, nobody has questions.
It's crazy.
Even about my episode.
I know.
You just watched it.
We just watched it. And we did determine that...
Let's see. Blue Origin just tested the new Shepard on its 10th flight. They also showed off a new video for what the new Glenn is going to look like. We got a really cool new picture of the supermassive black hole at the heart of the Milky Way. Not from the Event Horizon Telescope, but sort of the next best version of it. Let's see.
There's another one that says here, the oldest rock found on the moon, ? Scientists discover what may be Earth's oldest rock in a lunar sample returned by the Apollo 14 astronauts.
There's a new theory that there's no Planet 9, but actually a big disk of icy material. I don't know if you covered that.
Yeah, we went over that, which there was, because what's funny about it is there was something that came out last year from a bunch of students at CU that suggested kind of the same thing. This one was a little bit different. So different theory, but it's kind
Yeah.
of roughly the same idea, saying that there's probably a collective mass somewhere that could be perturbing those orbits.
Yeah. Um, uh, there was a meteorite strike during the lunar eclipse.
Oh, yeah.
Yeah.
And a lot of people thought that was super cool. I thought it was cool that people saw it because they were looking at the moon.
Yeah.
Um,
Well, I mean, these things are called transient lunar phenomenon. Anyway, TLPs, and for the longest time, scientists didn't think this was a real thing, and amateur astronomers were saying, "No, no, no, we saw something flash on the moon. We saw an asteroid strike," and but now it's it's science. Everyone agrees these things are happening all the time, and we're seeing tiny space rocks crash into the moon and explode and release all this energy like a little bomb. And
yeah.
uh, and now there are telescopes that are scanning the moon all the time, waiting for these moments. But the fact that it happened at totality, tons of people saw it. There's lots of images of it. Yeah, it's the real deal. Pretty cool.
Yeah, and Stealth, you asked how they date rocks, but it looks like Hazo covered it. So you can do radiocarbon, but there's, Ruru, you're right. There are other elements other than just carbon that you can use when doing some kind of radiometric dating. Um,
Saturn's rings are only 10 to 100 million years old, which is
yeah, yeah.
a mind-bending and kind of terrifying thought.
Yeah, so the rings aren't even that old and they're not going to be there
Yeah.
that long. So it got married pretty young. Well, the rings are pretty young. So the ring is young. And then
Yeah.
I tweeted about that. I was trying to be tongue in cheek saying that
But it's such a
it's
weird thing
divorcing
because
soon too.
you know anytime that we find out that we're at a special time in the universe, in the solar system, it makes us feel bad, feel weird, right?
Hmm.
That the general thinking among astronomers is that we're not in a special place, we're not at a special time, nothing special.
Right.
Right?
Nothing.
And yet we've got a couple of things that seem a little special. One is the fact that we get a chance to see eclipses at all, right? Like in just a few tens of millions of years, you won't see eclipses anymore because the moon is slowly drifting away from the Earth, and eventually it's going to be too small to properly cast a big shadow across the sun.
Right.
That's weird. And now it turns out the rings, like one of the most dramatic features in the entire solar system, is brand new. And if we'd been here, the dinosaurs didn't see the rings on Saturn with their
Hmm.
telescopes.
Right. And that's
Yeah,
crazy. That's
yeah,
crazy.
yeah. So
Um,
that is really freaky, and
yeah.
I don't like it at all. And I'm waiting for someone to overturn this. Like, oh no, wait, we were wrong. Saturn's rings are formed with the planet. And so, like, does that mean that at one point in the past, Jupiter had rings like Saturn, bigger, better? We
Right.
gobbled them all up. So
Right. Yeah. And finding out that these things, someone just said, so the rings are going to fall in. Yeah.
yeah,
Yep.
yeah, the rings are going to crash into the planet and be gone.
Hmm.
So it's such a weird thought.
Yeah. And I would love to be able to see that. How cool would that be just to see parts of.
Well, it's happening all the time.
Right. It's
Happening
happening.
right now.
Right. I was going to say see parts of it because it's not going
Yeah.
to be just one event, guys. It doesn't work
No,
that way.
no. It's this nonstop grinding away as tiny little pieces of the rings just fall
in.
It's happening right now today.
Right.
So, and eventually they'll be out of ring material.
Yeah. And I mean, I would love to see more significant impacts, things like that in the future.
Yeah, like Comet Shoemaker-Levy 9.
Right. Right. With Jupiter. Yeah.
Yeah. Yeah. And that was such a crazy thing to be able to see these bruises of a comet smashing into Jupiter. And that was something that nobody really thought that we would ever see.
Yeah.
And we saw one, and we happened to have the right telescopes to be able to see it. I mean, you can imagine, if it happened now with the Juno spacecraft at Jupiter.
I know.
But
that'd be so cool. But
yeah.
someone just said, well, Jupiter has rings. Jupiter, all of the gas planets have rings.
Terrible rings, like tiny little faint rings made of dirt and sadness. So,
Fraser hates Jupiter.
Jupiter's fine. I love Jupiter. One of my favorite planets after Saturn.
After Saturn. Yeah, Saturn's really, really cool.
Yeah,
But
Mars is pretty cool.
you've seen that exoplanet. It's my favorite exoplanet, the J1407b that has the crazy ring system. Crazy ring system. I forget. Joe
Wait,
maybe can look it up.
what?
Yeah, it's
Exoplanet with a ring system?
yeah,
Are
J1407b.
you sure?
Mm-hmm. I think it was discovered in 2000.
J1407b.
Yeah.
It's not a planetary ring system though. It's a stellar ring system.
What does that mean?
Oh, yeah. Wait. Yeah, the rings go around the star system.
Mm-hmm.
Oh no, a planet with a gigantic ring. Okay, I take it all back. Yeah, okay, never mind.
Yeah,
Yeah,
no,
no,
it's
you're
my
right.
favorite.
Yeah, so they were watching the like
They were
who knows
well. I
my
can
favorite.
actually show you in Space Engine.
Yeah.
It's really cool. But they
Yeah.
were watching the star's light going through those rings.
Yeah, and they could see
The
that.
transit.
And this is the way they've detected rings around an asteroid too.
Mm-hmm. Yeah, that one's my absolute favorite. I think it's about it's easy to remember because it's about 420 light years away. Hey, you've got to try. You got to try to find ways to remember these things.
Right, of course.
Yeah, and the rings.
Whatever you're talking about, it's no big deal here in Canada. Whatever it is that you're bringing up,
I know.
something fully legal in Canada.
Right. The rings have an outer radius of 90 million kilometers.
Yeah,
that's insane. And so yeah. Oh yeah, you can see it right here. Well, actually, I'm blocking it with my cam right now, but you can see we're focused on the star. Okay. But you can see that ring system back there, just with that planet.
My God, it's full of rings.
Yeah, isn't that crazy?
So did you crank up your with the new computer? I saw you were testing out Space Engine. Is it greatly improved?
Oh yeah, and I also have a 144 hertz monitor. So. Well, that's nice for me, but not for anybody seeing it. It's nice for me.
Yeah, that doesn't.
It's amazing for me.
Go out the stream, does it?
No, it doesn't. No, but it is
somehow improving everybody's monitor.
That's something I like. Show off. Hey, it makes space amazing. This is amazing to see space like that.
I'm jealous.
It's chaos. Chaos goes, well, good for you, Sky.
Way to go.
But I think people can see that it is better. I think the quality of it. People were saying it looks a lot smoother because before this thing was just kind of killing everything. Space Engine's become really robust.
Got the thing that's rendering separate from the thing that's
Yep.
outputting the stream. So have you got some kind of video capture card in your streaming machine, and then it just goes from the output from the one computer to the input?
Exactly.
That's really cool.
Yeah, it's an Elgato. I can link it to you too. It's an Elgato.
Yeah, I think I'm gonna get one because I want to swap out my camera with the DSLR for doing the live streams, and the only way that I can do that is I can do HDMI out from my video camera or from my my DSLR and then into the computer. So does it do 1080 or 4K?
1080.
Okay.
Yeah, I think there is one that they've made recently that does 4K. Yeah. I think that's a newer one than I have. The one I have does 1080, but I think Elgato's put out a 4K one now. Yeah, someone just said you can get a 4K one. So
yeah, I've got a Lumix GH5, and for all the wonderful things that it doesn't have a way to connect directly to a computer.
Oh,
and do a live view through the computer. So you have to do an HDMI. So the Sony ones, I want to get a Sony camera, but yeah, mine won't do it.
Yeah, the new one is 4K 60 FPS. Yeah.
Perfect.
Which is pretty new.
All my videos are 4K 60 FPS, so that would be sweet.
Yeah, and YouTube doesn't allow 4K yet, so.
Oh yeah, it does.
No, it doesn't.
It does.
Not YouTube. I'm sorry, Twitch. Just joking. I'm talking about Twitch. Sorry, right. Brain is so not working yet, and I don't know
Twitch
why.
Listening, man, are you gonna get censured? So be careful.
Yeah, no. So Twitch doesn't have that yet. It will be interesting to see. I don't know. What's a brain? I know. Bill Nash says, which DSLR? I use an app to capture video from mine over USB instead of HDMI.
Yeah, mine can't use USB.
Yeah. Never on the front page again, ever. I've been blacklisted.
Yeah, you've been blacklisted.
I'm just joking, Twitch.
Yeah, sorry, Twitch. She's sorry.
So yeah, that's, I mean, this, and it is a nice setup. I think it does run smoother. People were saying, because usually what was happening is the CPU would get going, combined with the GPU, all of that, when moving around in space, and it would start to kind of be more pixelated. The camera could also be pixelated. That's more of a bit rate thing, but yeah. Skylias.exe.
We know how long a day is on Saturn. Did you cover that?
Isn't it around the same as Jupiter? I mean, they're rotating pretty quick. Jupiter's around 10
right.
hours,
So
right?
Saturn has been a tough one for them to figure out how long a day is, and to the exact second. And so they figured out a way to test to where sort of the motions of the planet, there are sort of disturbance in the planet that are echoed in the rings, and they're able to then track the rotation of the rings to be able to determine how long the day is on Saturn. So no, it's a different number than Jupiter.
Yeah. I forget what it is
10
though.
hours and something. So
yeah, Jupiter's just barely at 10 hours, I think, right?
Yeah, and so they only just finally got a number.
Right. Okay. Yeah, and that's true. I remember that one being a little bit more complicated, the rotation of Saturn, than say Jupiter. There's so many other things though that
cool picture of planetary nebula from the European Southern Observatory.
Looks like they're trying to do how to escape a black hole with simulations.
Yeah, I haven't seen that one. I don't think you can. I mean, there are ways you can survive as long as possible with simulation.
Right. Yeah, I'm just putting it in your Discord. It's how to escape a black hole. Simulations provide new clues on what's driving powerful plasma jets, interplay between twisting magnetic field lines, negative energy particles produced, but they put negative energy in quotes.
Negative energy?
Negative energy. Yeah. I don't know what that's about. I mean, we have so many of these.
Oh, right.
Right.
I wonder if they're talking about like Hawking radiation. Oh, I haven't. This is brand new. I haven't seen this. So
I know. These are some of the ones. I haven't even looked through them. I was gonna go through some of this.
Today just posted on Twitter about it. No, those guys.
Negative energy must be political, Bill.
Yeah, please, no negative energy. It's positive vibes.
Wait, Universe just posted on Twitter? No, Universe Today did not. No, Universe Today did not. Did you?
Didn't I tell you the terrible secret?
Yes, you could tell everybody too, though.
Let me see what I just posted on Twitter. Yeah, we the Planetary Nebula and you're talking about the New Glenn, right? I think that's the one that you're talking about, not the black hole. Right. So we just posted a picture of the New Glenn rocket.
Yeah, this one. Orange guy. You guys are cracking me up. Yeah, no, I'm actually on your Twitter right now. We're looking at your Twitter. We're creeping
Which
out.
one,
So
mine or Universe Today's Twitter?
Universe Today.
Okay.
Right.
They're both me.
Right. They're both you. Fraser is Universe Today. Universe Today is Fraser.
Yeah.
Yeah, this is.
Oh, there you go. It was astronomy. See, Astronomy Cast is in me.
Right.
Yeah.
That's you and Dr. Pamela.
Yeah, and I think Pamela or Susie's probably the one posting to the Astronomy Cast feed, but I'm the one who posts to my Twitter and the Universe Today Twitter. Yeah, no, all I do is I'm testing stories. So if you follow me on Twitter, you are helping me figure out what kinds of stories people are interested in. And so in the morning, I go through all of the interesting news that's broken in the last 24 hours, and I queue them all up over the course of the day, every hour or so, with the cleverest title that I can think of and a cool picture. and then I look at the stats on Twitter analytics to see which stories people are really excited about and which ones people don't care about. And
Right.
so that way, we don't have to bother writing stories about topics that nobody wants to learn about,
Yeah.
and we focus on the ones that we do. So
So you make clickbait, but good clickbait.
I guess, I mean, it's like like everything
I
is
wouldn't.
clickbait,
Yeah.
really, right? I mean,
I
when
wouldn't say this
you
is
are
clickbait, guys. I'm looking at your Twitter. I wouldn't say this stuff is like.
well, I mean, the point is like I'm trying to come up with like there's stories that I think are interesting, and I think each of the stories that I post onto the Universe Today feed I think is interesting
Mhm.
and worth us reporting on.
Yeah.
But I also know that some stories just don't capture people's imagination, and so I try to give each story the best addition that I can. I come up with the best title that gets across, that is both accurate and entertaining and sometimes silly. I try to do the best that I can, and then I let them all, the science tell me which ones I should actually hand off to the writers, because it costs money, right? I have
Right.
to hire a writer to spend a couple of hours to write an article and interview the researchers. And we only have so many hours in the day, and I only have so much budget.
Right.
So I have to use my money very carefully. And so that's the method that I use to decide which stories we're going to report on and which ones we won't.
Yeah. Um. Let's see here. How about making titles that have nothing to do with the article?
Yeah,
See,
exactly.
yeah,
Yeah.
that would be.
10 things in your refrigerator that could kill you. Yeah.
And then they open it up and it's
And it's just,
space.
yeah, just a story about space.
I'd be okay with that. No, no,
Yeah.
no. But so JH, you just asked, well, like that unscattered mass versus scattered mass. What's the importance of that? I think he's talking about
Were you talking about the
Planet Nine,
image Jupiter gone sexual? Are you
maybe.
talking about the image of the supermassive black hole? It's just a new technique that they used to be able to. I don't know if you can show the picture because it's really cool.
This one.
I don't know.
Yeah, the simulation scattered. Oh, yes, this one. Okay, that's what JH was talking about. All right, yeah, no, it's up on the screen now. It is
Yeah,
really
okay,
cool.
great. Yeah. So what's going on here is that, let me just pull up the story here. Like we're still waiting on the Event Horizon Telescope, which is going to be this amazing combination of radio observatories around the world that are going to be able to image the supermassive black hole around the at the heart of the Milky Way. And the resolution that's going to be that this group of telescopes is going to provide is going to be down to about 15 micrometers,
Mm-hmm.
right? So micro arc seconds. So the entire sky is 360 degrees.
Oh
One
yeah. Mm-hmm.
degree, 1 degree is about twice the width of the moon. Astronomers break a degree into 60 minutes, and then they break an arc minute into 60 arc seconds, and
Yep.
then they break an arc second into 1,000 micro arc seconds. So it's a very, very tiny, they describe it as like the thickness of a hair held at, I don't know, 100 kilometers away or something like that, right?
Mm-hmm.
And that's the level of resolution. And the only way you can have that level of resolution is with an enormous interferometer, where you have a whole bunch of telescopes that are across the entire planet, and they essentially work together to create a telescope that is as big as the entire planet. And so we're still waiting for that first image that's going to come from the Event Horizon Telescope. But these images come from I think it was about 15 different telescopes across the Earth. The VLBA, ALMA, IRAM 30 meter, the Green Bank Telescope, etc. And so this image, if you see the top one is what they think is what the supermassive black hole is probably going to look like, what we're going to see from the Event Horizon Telescope.
Uh-huh.
But the problem is that the light is being scattered by dust that is surrounding the supermassive black hole. And so on the right hand one at the top is what it would look like once it had gone through that dust. And
Right.
so then the astronomers are going to need to have some kind of technique to be able to see through that dust. And that's you can see the bottom right is the scattered image that they did see with the radio telescopes, and then the one on the left is after they'd done their processes to be able to clean up the data to be able to show closer to the supermassive black hole. So it's still not quite as tight a resolution as you want,
Right.
but we're getting closer and closer and closer. The other interesting thing that came from this is it turns out that the jets that are coming off of the supermassive black hole, one of them is pointed directly at the Earth. So we are staring right down the sort of right down the hole
Right.
into the supermassive black hole as the jets. Now it's not actively feeding, so we're seeing just tiny little puffs of material coming our way, but still, it's pretty fortunate that we're getting a view right down into the part of the black hole. So we are still another couple of months from that next level image, but this is the best that's been taken so far. And it's really hard to just to communicate how teeny tiny these images are, how small of a region, right? So Saturn is about 1 arc minute across. No, 7. I'm trying to think now. 30 arc seconds is Saturn. So Saturn would be dozens of times bigger than this tiny little spot.
Yeah.
Oh, micro arc second. Or is it a mill arc second? Mill arc second. Sorry.
Oh, okay. I got confused about
a micro arc second is a. I'm trying to think. Maybe it's a millionth of an arc second. Anyway, I'm not gonna. I'm gonna stop trying to make these calculations in my head right now.
Yeah, it's not great to do live.
Yeah.
I usually stay away from it, and everybody gets mad at me for it. But I'm like, you guys aren't paying me enough, and I'd be doing like 10-minute streams, and it'd be over. It'd be done.
It's a micro. So it's a millionth. it's a millionth of a arc second.
Right.
Yeah.
Or you can just say yonders. We just say yonders here.
Is that what you do? You say yonders?
Yeah, just about 10 yonders that way. And that's how you bypass all that. Yeah.
Yeah. How many parsecs?
So let's see. There's maybe such a loose. Yeah. So when is this telescope launching? The one for the black holes?
Well, the Event Horizon Telescope is the one that's this worldwide network of radio telescopes, and it already took its picture. It's just that the astronomers are trying to interpret and interpolate the data and to produce the final image. So it's the crunching the data part that we're in right now. And the picture was actually taken about a year and a half ago.
Oh, really?
Yeah.
See, I've never even heard about this telescope, but this is why we love Fraser, because Fraser knows all of it.
Telescope, really?
I've never heard about it. Or maybe I have, but I don't remember.
Horizon around a supermassive black hole? No? Okay.
Not the Event Horizon Telescope, no.
Yeah. So the Event Horizon Telescope isn't a telescope. It is a network of telescopes, ground and space-based telescopes. Like one of the interesting ones was in Antarctica. There's a radio telescope in Antarctica that took an image of the supermassive black hole, but then the problem was they couldn't get the data out until the Antarctic summer because it's just too much data. So they had to fly out the hard drives containing all the data that they had gathered, and now they've got all this data. Because the thing with radio telescopes is that you can perform interferometry. You can make a whole bunch of separate radio telescopes act like one big telescope, and it's better than just adding up the light of all the different telescopes. Like if you had, I don't know, 5 telescopes side by side and you wanted to make them be one big telescope, you would essentially get the total surface area of all of those telescopes.
Right.
But there's a special trick you can use called interferometry, where if you can line up the wavelengths to the individual wavelength, then you can have it act like a telescope that is the size of the width of the telescopes.
Right.
And so it's the baseline, and you get the resolution, but you don't necessarily get the light gathering power. But it allows you to resolve very tiny objects like a supermassive black hole at the heart of the Milky Way.
Right, and that's I think we used like adaptive optics.
Well, adaptive optics is a way to cut out the Earth's atmosphere.
Right.
Interferometry is adding the light from a whole bunch of different telescopes to act like one big telescope.
And they use both of those things when detecting Sagittarius A star.
I don't know whether they don't. I don't think they have to use adaptive optics because they're doing it in radio waves,
Right.
right? So very long wavelengths. But
Yeah.
like the very large telescope, the one down in Chile, that uses both adaptive optics and interferometry. So they've got 4 telescopes, 8.4-meter telescopes that can all look at the same object, and the separation of the telescopes acts like one big telescope that is the size of how far apart they are. Right? If you put one telescope on both sides of the solar system and had them look at the same object, you would get a telescope that is as big as the solar system.
Right.
And that's the magic of interferometry. But it's only in terms of resolution. You're still only gathering enough photons for the 2 telescopes, but you're getting the ability to resolve tiny details based on if you had a telescope the size of the solar system. And let me tell you, a solar system sized telescope would be very, very handy.
Right.
So with the Event Horizon Telescope, they made a telescope the size of planet Earth.
Yeah, no, it looks like Dr. Andrea Getz did use interferometry and also adaptive optics to look at the. She did.
Yeah, she did. I mean, Andrea Getz did her research on just discovering the supermassive black hole in the first place.
Right.
I mean, 20 years ago,
Mm-hmm.
I'm going to think. Maybe, yeah, almost.
Yeah.
So I'm not sure which instruments were available, but there's like the twin Keck observatories.
Yeah,
I
she
believe,
said with the
were
Keck telescopes,
interferometry thing.
yeah.
Yeah, so the Keck telescopes, they're one of the first working interferometers. And it's very technical to be able to do this with visible light because how small the wavelengths of light are, right? They're nanometers across. And for you to synchronize the wavelengths perfectly is very difficult. And so you can only do that in real time with visible light, but with radio, because the wavelengths are so large, you can do it after the fact. You could point your telescope at some thing in the sky. I could point my radio telescope at something in the sky several thousand kilometers away. As long as our clocks are good,
Right.
we can gather the data together and we can have a computer merge them together and produce an image that acts like a telescope as big as the distance between you and me.
Yeah. Yeah. Because I think that's, she definitely used both techniques. So that's why.
Yeah. Right. So Keck has both an adaptive optics system on board as well as an interferometer.
Right.
And the new telescopes will do this as well. But
yeah,
interferometry is tough. And of course, the thing that we're always hoping for, Pamela and I always wish for, is an interferometer in space, because then you could fly like 5 Hubble Space Telescopes in formation several hundred meters apart. And as long as you line them up perfectly, you could get a telescope that is as big as the separation.
Right.
And that would allow you to resolve incredibly detailed features, say, on other planets.
Yeah, I can't believe I haven't heard of the Event Horizon Telescope. I probably have.
Yeah, I'm sure you have. Yeah,
There's probably no way
we're going to see the first picture of a supermassive black hole. And it's going to be happening soon. But maybe the picture was taken before you really did a lot of astronomy streaming. Like, we're waiting a long time.
Yeah. So when did they say that they took it? Do you remember?
They took it summer of 2017.
Oh no, I was pretty hardcore into it. Well, I wasn't getting like press releases and stuff like that. So there's potential that I didn't.
Yeah.
But yeah, interesting. Yeah, because they've been talking about this for a while, it looks like. And when are they expecting to have that information in?
Spring.
Okay. Well, that's really cool.
Ooh,
yeah, because I feel like I probably do know about it, and it's just something that I'm not remembering right now. I feel like there's so many different telescopes too, but this is why you're amazing at this stuff, because you know about all these upcoming ones, what's kind of going on with the current ones. My brain doesn't track that as much.
Well, it's a funny thing. Like, for the longest time, I would constantly surprise Pamela with all the recent news, because my job is to just be on top of all of the space news all the time, right? To just be encyclopedia of everything that's going on right now. But Pamela was more focused on research and was not as up to date on all this stuff. So I
Mm-hmm.
constantly surprise her. But now that she does her daily space thing on Twitch, she is totally up to speed on all the stuff. It's quite amazing as you start to you have your sources and you're watching this stuff and you're reporting on the stuff, and you learn by teaching. You just get more and more up to speed to it, and it all fits into this bigger picture in your brain.
Right.
And so now I can glance at a news release and go, oh, I see what the new news is, right?
Mm-hmm.
And not necessarily have to read deeply through it because I don't need all the background. I just see
Right.
whatever's the new insight, right?
Yep. Absolutely. Um, Wait, let's see. There was somebody just said
Someone
something.
noted my name. I had the name first.
Wait, what?
Kelsey Grammer Fraser from Cheers. Yeah. So I had the name first.
Yeah. It doesn't have to
Yeah.
be simultaneous for. Doesn't it have to be simultaneous for interferometry?
For short wavelengths like visible light, infrared, but for the longer wavelengths, radio, you can do it after the fact.
Yeah. Could we put one on the moon?
I mean, everything's harder to put on the moon,
Yeah.
right?
Right.
So yes, you could, but I mean, the moon is going to be a difficult place to get to, difficult place to land on, difficult place to work on. You want the so yes, but the moon's not anything special. I would rather just a big telescope built in space that just orbits the Earth,
Oh yeah.
has a space station attached to it.
Mm-hmm.
Astronauts can go out and tinker with it and upgrade the equipment,
Yeah, I agree with
and
that.
just have it be as big as, have it manufactured in space. That's the key, so that we don't have to launch it. Because the big problem right now is that when you launch a telescope like James Webb, it has to deal with the gravity of Earth for its construction, and then it has to be able to deal with, you have to have some way to be able to fold it up and be able to put it into a spacecraft, and then
Right.
it has to handle the rigors of launch, and then it has to be able to unfold into whatever final configuration you want it to be, which is crazy, right?
Yeah.
Like, instead you just like bolt the thing together in space
Yeah.
from parts, and then you're ready to go. If the telescope isn't quite accurate enough, just make it bigger,
Yeah.
right?
Yep.
Because there's no gravity, so it doesn't matter.
I'm sorry. I'm reading everybody's comments.
Yeah.
There was actually a really good question still, though, and it was. Sorry, I'm trying to get. Does the observation need to be simultaneous with
Yes.
interferometry?
Yeah, I mean, you need to have gathered data at the exact same time.
Mm-hmm.
That's the key. You have to match up your wavelengths to the wavelength. Like, if every peak and trough that's ever come from Andromeda has a number, right? 1, 2, 3, 4, 5, right? And you get to 45 bajillion 600 and yonders, then you have to match the exact same wavelength for all of the images that you took. And you can do that with a radio telescope because the wavelengths can be centimeters long,
Makes sense.
meters long.
Yep.
Right.
3D printers in space.
Yeah, there's some great 3D printers that are in the works. This company called Made in Space is working on this thing called the Archinaut, which is a 3D printer. It's kind of like a cross between a 3D printer and a spider. And so you fill up its buckets with just raw material like aluminum
Mm-hmm.
pellets or titanium, and then it just extrudes girders out of its spinneret. Like it poops them. And then it has these 3 arms that it pulls the girder, it's kind of like pulls the girder out, or I imagine like a clown, or a magician pulling a handkerchief out of their mouth. So it just pulls them out and then creates bolts and nuts and screws them together and just attaches things together, just builds your space telescope as it goes. Pooping titanium.
I know.
Yeah.
It sounds awesome.
Yeah.
Oh man. And then there was, I'd rather not imagine a
Yeah,
clown.
yeah. That's why I quickly changed it to a magician. A happy magician, not a terrifying clown.
Ooh, good question. What causes ultra short period planets?
I have no idea.
Me neither.
What's an ultra short period planet?
I'm wondering if that means its orbital period is super short, where they're pretty close into the host star. Is that what you mean?
There's a really obscure Astro PH, couple of Astro PH, like a hot Jupiter.
That's what I'm thinking. Like those hot Jupiters that can go around their host star in a matter of hours.
Yeah.
Yeah, less than 1 day
Like,
orbit
how
around
do
the
they
star.
get into that kind of an orbit? Well, I mean, in some cases, we think there's some kind of planetary migration that goes on in star systems, and this is one of the big surprises that we thought that we would be seeing other star systems like the solar system with
Right.
terrestrial planets inside, and then the gas planets, and then the ice giants, etc. Right,
Mm-hmm.
and we find all these really crazy worlds like these hot Jupiters and things like that around other stars, and so it helped astronomers realize that there must be some kind of mechanism that is pushing planets around from place to place. And now we know that the disk of dust that forms around a star acts like the brakes for planets. And so as planets are going around, as they're forming and they're going around in these disks, they're pulling material in from one side of the disk and the other side of the disk, and it causes essentially a motion inward or outward depending on the amount of material. And so you can get where the planets first formed and where they end up can be vastly different places.
Right.
Here in the solar system, isn't it kind of weird, right? Jupiter is the biggest, then comes Saturn,
Mm-hmm.
then Uranus is the smaller one, and then Neptune is a little bit bigger.
Mm-hmm.
And it's weird.
Yeah.
And also Uranus is flipped over on its side, which is also weird. And so the thinking now is that as this migration happened in the early solar system, Uranus and Neptune actually switched places
Yep.
in the solar system and could have interacted at some point. So with the hot Jupiters, we see evidence that planets clearly are moving a lot more rapidly. And in some cases, this could happen in a tremendously short period of time, like in tens of thousands of years, you could have these motions come very quickly.
Yeah.
So it's a pretty kind of amazing set of discoveries that were made.
Yeah, and that's one of the reasons that one of the many with the Juno mission was to understand Jupiter and its formation, giving us keys and understanding ideas about our own planetary, how everything actually started forming from that planetary disk into planetesimals into planets, how that all worked.
Yeah.
And so, but yeah, Juno. I mean, we learned that Jupiter we think is the first planet to form. I mean, it kind of makes sense and it's the biggest, but
Big.
but still, I mean, that was pretty cool. And as far as like some of these objects that we've seen with Kepler and the K2 and stuff being closer in, I don't think we have. I mean, right now we're just throwing out speculation on, well, maybe this came in this way, or I mean, you can, right?
Yeah, I mean, it's all about the disk that surrounds the star, and the planets form in that disk, and as they grow, they interact with the disk and material falls into them, and that produces a torque that moves them inward or outward, and it just depends on the amount of material, the distribution of matter in the disk. And there was this great, I mean, I don't know if you saw this image that came out a couple of weeks ago where they showed 20 different protoplanetary disks around other stars. It was a radio telescope image, and they're all different. You
Oh,
see ones that look like spiral galaxies, and ones that look like records, concentric rings on a record, all kinds of stuff. And so you can just see that, in fact, all of these planetary systems are different.
yeah. I don't think I actually saw that one. That'd be really, really cool to look at. How is the New Horizons probe going? They get a clear view of the object they were chasing. Yeah, they did. They did, boy.
Here's your image.
They're getting better pictures. I imagine they'll be even better later on too.
So you bring up that picture if you want.
Oh, that's it. Oh man, the tabs are starting to build up. The tabs are happening, guys.
That's what happens.
Oh, that's a really cool picture.
Yeah, and it's like you see all these different, and like some of them look like even like little galaxies.
They do. I love how space does this, though. It does this like several times over.
Yeah,
you
I
know?
talked to a couple of astronomers about this, and they're like, "Nope, not surprised."
Yeah.
Like we see this same formation. We see this going around black holes. We see galaxies have these spiral formations. So to like think that they're going to be in protoplanetary disks was no great surprise.
Yeah, like the planets can look like this, as we were just showing earlier, from anywhere from a black hole to protoplanetary disks to planets to galaxies. Yeah, this is pretty cool. I didn't see this.
Oh, cool. So new high-res images of MU69. That's amazing. Have you shown this off yet?
No.
I'm going to get a writer on this right away.
Yeah, if you want to link it, if you get someone on that,
Here.
we'll look at that. Oh my goodness. Yeah, this is amazing. That's pretty high res. Wow.
There. Assigned.
You've already assigned
I guess we should
it?
wrap it up.
Yeah,
Our time is over.
It is. It is. Thank you so much, guys. And check out Fraser's stuff. We are going to watch the Fast Radio Burst one because I haven't seen it yet with you guys. So,
right on.
All right. Well, take care then.
Thank you, as always, for having me.
Yeah.
And we will see you all next week.
Yep. Sounds good.
All right.
All right. Bye.
See you later.